Hey guys, so today's going to be a short lesson. We're going to talk about the factors that affect the rate of weathering. This is something you saw in the lab. Different things are going to cause rocks to weather at different rates, whether that be physical or chemical. So it's going to cause it to break down differently. The size of the particles, the amount of time it takes to make those particles, and things like that is all going to change based on a whole bunch of factors, which is what we're going to talk about today. And once we talk about today, we're going to see what happens if you have a rock or a wall or a mountain that's made up of different rocks that react differently, obviously, to the same conditions, because we would have just talked about that. And then finally, we're going to talk about what happens when you get that weathered material and you mix it with a little bit of life, what you get from that, which is actually really important for all of us to survive in our modern day society. All right, so I hope you guys are paying attention. I hope you guys have your notes out, and I hope you're ready to go. All right, guys, let's go. All right, so the first thing we're going to talk about, the first factor we're going to talk about that affects weathering is mineral composition. What does that mean? It means what minerals are inside your rocks. We talked about a whole bunch of different minerals. We didn't even scratch the surface, no pun intended, of all the ones that are out there. But one of the things that we did talk about is how some minerals are more durable than others. We talked about hardness. We talked about how some react with oxygen, or some can be dissolved in water, affected by acids more than other ones. Well, what minerals inside your rock is directly going to affect how fast your rock breaks down, because all those things I just mentioned are effectively things that cause your rock to break down, to weather. And so if you have a rock that's made out of a durable mineral, it's going to weather slower than if you have a rock that is made up of more easily broken down materials. So what minerals are the best at this? Well, silicates. We talked about this. Silicates are minerals that have a lot of silica in them. Remember, silica is the silicon and oxygen bonded in a tetrahedron, pyramid shape, all that stuff. Okay, this is a very, very durable material. If you've got a lot of this inside of you, you're going to tend to be able to take up a lot more wear and tear and be beaten up and still maintain your general shape and not break down very much. You still break down, but just very slowly, and it'll take a long time. The other hand, if you don't have a lot of silica, or if you have lower amounts or none, you're going to break down a heck of a lot faster. So if you have a rock that's made out of something that has no silica in it, something like galena or magnetite, okay, or calcite, these don't have silica in them, so they're going to break down really, really, really fast. Now, if you do have silica in it, the amount of silica you have is going to affect how fast you break down. Something that has a lot of quartz in it, quartz is almost pure silica with almost nothing mixed in except for a couple of impurities, you're going to be incredibly durable. You're hard. You can take a lot of, wind and water and things chipping away at you and hitting you and still stay there. You might break off a couple pieces, but not a lot. On the other hand, if you're something like olivine, which is still a silicate, but it's got a lot more magnesium and iron mixed in, you're going to break down a heck of a lot faster. Now, why is this important? Well, this is actually going to be one of the most important decisions that you make either in your life or for somebody else. And it's going to be one of the final decisions that you make in your life or for somebody else. Why do I say that? Well, because of the picture in front of you. Yes, I know it's two tombstones. I know it's a little creepy, but it's actually the best example of what we're talking about. The two tombstones that you see in front of you right now are made out of two different materials, okay? The one on the left-hand side, okay, is made out of granite, the one that says sweat on it, okay? Now, that's the individual's name. This individual died in 1868, and you can still read the date, pretty much his entire name, okay, and you can see a lot of detail on it. Why? Because it's made out of granite. Granite has a lot of quartz in it, high silica content. And so the granite tombstone is not going to break down nearly as fast. The tombstone on the right-hand side is made out of marble. You can barely read anything on it. You can read still died February 29th, but that's about it. Everything else has been kind of blasted away. This one is made out of marble, another popular stone that we use for grave monuments and tombstone markers. And a lot of people will buy the marble tombstones because they're beautiful and marble has this shine to it, but don't be gypped, right? When you go to buy this, unfortunately, we all have to do this at some point, either for ourselves or for somebody else or a couple of times, okay? They'll always try to upsell you the marble. Marble's more expensive. Okay, and so they'll try to upsell it to you. They'll try to get you to purchase it, and they'll show you it and how beautiful it looks. Don't be fooled. Marble tombstones, marble monuments are a waste of money. They will get worn down, and you will not be able to read them. Okay, if you've ever been to a cemetery or you see a horror movie and you see those statues of angels that have no faces and it's just incredibly creepy. Why? Well, because those statues were probably carved out of marble. And as the years went on, the weathering just took away all the features and the details, and you end up with these faceless, incredibly spooky statues perched on top of gravestones. Okay, if you build your stuff out of granite, it will last a heck of a lot longer. So if you take nothing else from this class, here's a selling point. Buy a tombstone made out of granite. Do not buy a tombstone made out of marble. Okay, now to kind of get on a little bit happier note, there is something else that you're going to purchase in your life that you might have to make this decision, and it's what you see in front of you right now. It's a countertop. Countertops are usually offered in lots of different things, but the 3 stone options that you get, which is if you ever redo your kitchen and you want a nice thing, is marble, granite, and quartz. On the screen, you're going to see 3 different ones sliding by. Now, a lot of people, once again, will try to get the marble because it's beautiful and it's pretty, but it breaks down. And why does it break down? Because marble contains calcite, and calcite is a mineral that reacts with acids, which is a really bad idea to put on a countertop. Why? Because as you cook and you cut that lemon or that lime, or you spill salad dressing or soda or coffee, guess what? Those are all acidic. What are they gonna do to your marble countertop? They're gonna munch away. So as nice as the countertop is that's on the screen right now, it's marble. It's also more expensive. Why? Because it costs more to ship, to maintain it, keep it nice and straight. It's harder to dig out of the ground and keep it nice and level because it also breaks much easier. It has a lower hardness. Don't be fooled and buy yourself a marble countertop. It's a waste. If your significant other, pushes you for it, go, no, I learned this a long time ago. Marble countertops, waste of money, no matter how pretty they are. Your second option, which is what you see on the board right now, is granite. Now, I just picked different colors that I found on like the Home Depot website, though this isn't the only countertop you can buy. But a granite countertop, heck of a lot more durable, less expensive than a marble countertop. Okay, and can take a lot more wear and tear because it doesn't have, the calcite in it. Okay, they're good. You want to get a granite countertop? It will probably outlast you. You got to take care of it a little bit because it's not 100% silica, so it still can get broken down a little bit, but it's good. But your best option is what you see on the screen right now. This is a quartz countertop. Now, these cost a little bit more money than a granite countertop, but they basically will last guaranteed for almost your entire life, if not past it. They need very little maintenance. Why? Because almost nothing's going to eat away at them because they're made of almost pure silica. So in your life, you want to buy a countertop? Buy a quartz countertop. They're big, they're durable, they're tough, and it all has to do with the mineral composition and how quickly it weathers. As weird as it is to think, you cooking and rubbing materials on this and dropping fluids on it and cutting and doing all this, you're effectively weathering your countertop. So if your parents are looking, you can chime in a little bit of advice and prove that the money that they spent on school was actually useful. All right, the next factor that affects weather is climate. When we talk about climate, we talked about moisture and temperature, okay? And this is going to have a huge effect on the type of weathering that you have and how fast it happens. If you have a climate that is warm and moist, so lots of water in the air and it's relatively high, you're going to tend to have more chemical weathering. So if you're in a place like Florida, Florida is going to have a ton of chemical weathering, okay? All that rain and all that other stuff, New Orleans, places like that, you're going to have a ton of chemical weathering. Whereas if you're in a colder climate where the temperature, kind of vacillates, it changes from time to time, you're going to get more physical weathering, particularly stuff like frost wedging. So in New York, we get frost wedging, which is why we get potholes and stuff like that in the ground, okay? So the type of climate that you're going to have has a dramatic effect on the type and the amount. The warmer it is, typically, the more chemical weathering you're going to get, and the more it fluctuates, the more you're going to get. So if you have a climate that's always cold, you're not going to get a whole lot of weathering. But if it fluctuates between hot and cold, you're going to get a lot. Now, these factors are going to cause what we call differential weathering. If you have a rock or a formation of rocks that has different minerals in it or different substances, so a little bit of limestone and then below that granite or stuff like that, you're going to get parts of the rock that weather differently. Basically, the resistant rock is not going to weather as fast, and the non-resistant rock is going to weather much faster. You see this in the background of this entire slideshow. You have this weird formation with this stacked rock on top. What does that tell you? That tells you that the stem part of this rock was probably less resistant and the big mass on top was probably more resistant. In the United States, we get a lot of these, particularly in the southwestern United States and places like Bryce Canyon and stuff like that. And these are what we call hoodoos. It sounds like a funny word, but it's just the type of formation, this uneven weathering that you see on the board right now. These are hoodoos, where you have this mass on top that is more resistant, and then the neck, which is less resistant. Kind of the general rule is where you have a lot of rock, that's going to be more resistant, and where the rock has gotten eaten away, where you can see it's thinner or been taken chunks out of it, it is less resistant. This is what we call differential weathering. The picture in front of you is something that you quite often see as a question on a test that talks about differential weathering. So if you look here, waterfalls give you a great example of differential weathering. Why? Because as this water is moving, it's going to weather away at certain layers of rock and not at the others. So if you look here, you see how the dolostone here is pretty solid. Not a lot of it's been taken out by the waterfall. But the shale, see how it's got this big bite mark? This tells you that this is more resistant than this. See how this limestone here, okay, has, got, a little bit taken out, but not too much, okay? But this guy is going to be eaten away more than this guy. And you see how this huge chunk right here has been taken out. So these guys are all weather. Much more than this guy up here. So this would be an example of a differential weathering. The shales would have gotten eaten away really fast, and the dolostone would not. Okay? This is the same basic thing here. So if you were looking at this layers, which one would be the most resistant? Would probably be A. See how that one juts out like that? Doesn't look like a lot of it's gotten eaten away. A or C. Okay? D maybe even as well. Okay? But the least resistant of all, if you were going to do it, is definitely B. I come to think of it, would probably say D is the most resistant, then A, then C. Okay, and then B being the least. Now, a natural result of weathering is the creation of soil, of dirt. What is soil and dirt? Well, soil is basically a mixture of weathered material, so stuff that's been broken off of other rocks, and organic or biological material. So you take a mixture of the bedrock that's gotten broken down, and the plants and the animals that have died, and sit there, you mix that all together and you get what we call soil. Soil is a mixture of both living and non-living material. Now, there are two main types of soil. There's what we call residual soil, which basically means that soil came from that area. The bedrock there, the crust there got broken down, got mixed with the things that lived there, and turned into the soil there. Transported soil means that the weathering happened someplace else, the material was created someplace else, and it was brought to you. Now, when we talk about soil formation, soils form in a very simple way. What you basically start out with, if you see the picture, is you start off with bedrock. That bedrock slowly starts to get broken down, okay? Frost wedging, plant action, biological activity, chemical weathering, doesn't make a difference, okay? And it starts to get broken up. Slowly over time, life also starts to live on top of that area. And as the process keeps going, the material gets broken down smaller and smaller and smaller, and you get more and more biological activity as more things live their lives, and die and mix in. And eventually you go from solid rock all the way to a well-developed soil. You guys learned this last year when you did ecological succession. You start off with a place with no life, then you get simple lichens and stuff like that. Those plants break down the soil and eventually turn it, or the crust, and eventually turn it into soil, and that soil becomes better and better. As the soil gets older and older, we say it matures. Eventually, it's going to develop into different layers of soil like you see in the picture above you. We call these layers horizons. Now, you don't need to remember the order, but you do need to know that there are different horizons. The topmost horizon is where you find most of the living material, the plants, the earthworms, and the bugs. And the bottom horizon is where you have the crust. That's where you're not going to have anything living. Okay, so the top stuff is the living stuff. The top horizon is the living layer, and the bottom horizon is the crust. All right, so if we look at the soil here in New York State, the soil in New York State is mostly transported, and it was mostly brought here during the last ice age. If you're looking at the picture in front of you, you can actually see that. Okay, all the different colors and things aren't that important, but if you look, you see a lot of this term glacial till. Most of the soils, including the stuff down here on Long Island, was formed during the last ice age. So the soil that we have here didn't originate in New York, it came from other places, mostly Canada. All right, guys, so I hope you enjoyed that. Sorry, it went a little longer than I thought. So make sure that you have all this stuff down. You have a homework assignment tonight. Check your Google Classroom. And I hope everybody's safe and I hope everybody's healthy. And I will see you guys later. All right, guys. Bye. Peace.